Good morning to all. In today's class, we will discuss multi-threading. So, the entire fourth unit is on multi-threading. Okay, in fourth unit, we have only one concept, that is multi-threading, and which is very, very important for exam point of view and as well this interviews point of view also. So when you go to any interview, first they will ask questions on multi-threading, because multi-threading is the heart of Java. That's why please follow carefully. So very, very important. Okay. Now, first we will see the basics of multi-threading. Okay. So here we multitasking. So what is multitasking? Executing several tasks simultaneously or parallelly is called multitasking. Okay, in day-to-day life we are doing multitasking only. Okay, we are not doing single task at a time. So parallelly we are doing multiple tasks. Okay, that is nothing but multitasking. So executing several tasks or multiple tasks simultaneously or parallelly is called multitasking. Okay. Next, in the exam, if the question is explain about multitasking, means with example means you have to explain this concept. Now, coming to multitasking, there are two types of multitasking. They are process-based multitasking and thread-based multitasking. Now, we will see what is the difference between these two types of multitasking. So, in multitasking, we have two types. They are process-based multitasking and thread-based multitasking. First, we will see process-based multitasking. Then, after that, we will see thread-based multitasking, and then after completion of these two, you can see what is the main difference between these two types of multitasking. So coming to the process-based multitasking, so here see here I will read out: executing several tasks simultaneously, where each task is a separate independent process, is called process-based multitasking. Here we are doing several tasks, but each task is a separate independent process. Okay, then it is called a process-based multitasking. So I will give you one example on process-based multitasking. So here, while typing a Java program in the text editor, we can listen MP3 audio songs, and at the same time we can download a file from the internet. Here, how many tasks we are doing parallelly? 3 tasks. We are typing a Java program, and we are listening MP3 audio songs, and we are also downloading a file from the internet. So we are doing these 3 tasks parallelly or simultaneously, but each and every task, if you observe, it is a separate independent process. If you type a Java program, that is one separate independent process, and if you listen MP3 audio songs, that is a separate independent process, and when you download a file from the internet, it is also a separate process. So all these here, how many processes are there? We have 3 processes, and all are separate and which are independent processes. Okay, so here all these tasks are executing simultaneously and independent of each other. Hence, this type of multitasking is called process-based multitasking. Here, multitasking means doing several tasks simultaneously, and process-based means each and every task is a separate independent process. So here, this is the best example for process-based multitasking. In day-to-day life, we are doing process-based multitasking only. Next, this type of multitasking is best suitable at operating system level. Next, coming to the thread-based multitasking, this is important. Now in multi-threading, this thread-based multitasking is important. So what is thread-based multitasking? So executing several tasks simultaneously, where each task is a separate independent part of the same program. This is important. Here we are considering only one program. In that program, okay, we are considering multiple tasks, but all the tasks are parts of the same program. Now try to understand the difference between process-based multitasking and thread-based multitasking. So here also we are executing several tasks simultaneously, but here each task is a separate independent part of the same program. Okay, from one program we are considering multiple parts. Okay, that is separate, independent, and each part is independent to each other. So here this type of multitasking is called thread-based multitasking, and each independent part is nothing but a thread. Okay, here we are taking several independent parts from the same program, and each independent part is nothing but a thread. That's why it is called thread-based multitasking. So in thread-based multitasking, we are considering only one program, and from that program we are considering several independent parts, and each independent part is nothing but a thread. Okay? So it is called thread-based multitasking. There is a lot of difference between these two types of multitasking, that is process-based multitasking and thread. Here each task is a separate independent process. Okay, here all these three tasks are separate independent process, but here also we are taking separate independent parts, but from the same program we are considering these separate independent parts, and each separate independent part is nothing but a thread. Means here we can think like that, we are considering one program on multi-threading. Inside from that program we are taking multiple threads. Means within the same program we are writing, program means file, no? So in Java program we can write any number of classes, no? So like that, in a multi-threaded program we can take multiple threads. Okay, we can take multiple threads. Each thread is nothing but a separate independent part of the same program. So this is very, very important. Now when I explain the programs on multi-threading, then you can understand more clearly this definition of thread-based multitasking. Okay. Next. Thread-based multitasking is best suitable at programmatic level. Here it is best suitable at operating system level. Here it is best suitable at programmatic level. Next. So Java language provides a built-in support for multi-threading. Okay. So Java provides a built-in support for multi-threading. Being a programmer, we have to know how to use and how to use it we have to know, and we are not responsible to define the required functionality. Hence, developing multi-threading applications in Java is very, very easy. Okay, why? Because whether it is a process-based or thread-based, the main advantage of multitasking is it improves the performance of the system by reducing the response time. What is the advantage of people? The question is, what is the advantage of multitasking? Whether it is process-based or thread-based multitasking, then your answer must be, okay, the main advantage of multitasking is it improves the performance of the system by reducing the response time. So that is the advantage of multitasking, whether it is process-based multitasking or thread-based multitasking. So here, what are the applications of this multi-threading? Or implementing video games, multimedia graphics, animations, etc. So to develop this type of applications, we have to go for multi-threading. Next, Java provides built-in support for multi-threading by providing a rich library, that is thread class. So using thread class, we can develop multi-threading programs, or using runnable interface, we can develop multi-threading programs. So these two are very, very important in multi-threading. So thread is a predefined class and runnable is a predefined interface. So these two are very, very important to develop or to write programs on multi-threading. How to write, I will explain later. First understand. So thread is a predefined class and runnable is a predefined interface. Like that, we have so many classes related to thread. That is in Java API, that is thread group is one class, thread local is one class. Like that, Java provides built-in support for multi-threading by providing a rich library, means predefined classes and interfaces already they have developed. Already here I explained. No? Okay, being a programmer, we should know how to use those predefined classes and predefined interfaces. So we are not responsible to define the required functionality. Okay, we need not worry about the low level things. Okay, first we should know what are the predefined classes and what are the predefined interfaces which are useful to develop the multi-threading applications. That's why we need not worry about the low level things. So that is the advantage of this multi-threading. Okay. So this is the introduction about multi-threading. Okay. Now we will see. Okay. How many ways are there to create a thread or to define a thread? So here we can define a thread in the following two ways. They are by extending thread class or by implementing runnable interface. So using these two ways, we can write the multi-threading programs. Okay. So what is the first one? By extending thread class, extends thread, because thread is a class, no? Thread is a predefined class. So by extending thread class, we can write programs on multi-threading, or by implementing runnable interface also, we can write the multi-threading programs. So, runnable is a predefined interface. So we have to implement runnable interface to write the multi-threading programs. So there are only two ways to write the multi-threading programs. They are by extending thread class and by implementing runnable interface. These two are very, very important in multi-threading. Okay, now we will write the programs first by extending thread class, next by implementing runnable interface. Try to understand. So writing the programs on multi-threading is very, very easy if you understand these two concepts. Okay. Now first I will write the multi-threading programs using thread class. So that is nothing but defining a thread by extending thread class. Understand this program carefully. I will explain each and every line. Now here we are taking one class myThread, because we are writing a multi-threading program by extending thread class. For that reason, I am taking one class, that is class. The name of the class is myThread extends thread. Okay, this is the one way of writing or one way of creating thread. That is class myThread extends thread. Okay, so inside this class, what I have written? So inside that class myThread, I have written only run method. So the syntax of run method is public void run. Okay, inside that I have written one for loop which is executed 10 times, because I have taken I is equal to 0, I less than 10. No? So this for loop is executed 10 times. Inside the run method, I have written only for loop. This is the body of this run method. This is opening brace, this is closing brace. So inside the run method, I have taken only for one for loop which is executed 10 times. So this is the body of run method. So this is the class opening myThread and this is the class closing. So understand this class. So it is nothing but a thread. So if you want to create one thread, you have to write the class like this. So each class is nothing but a thread, but when it behaves thread means that class must extend the predefined class thread. So if you take class myThread extends thread, means this is behaving like one thread. Next, suppose if you want to create two threads, then how do we create is class myThread1 extends thread and write the run method in this one, and take one more class myThread2 extends thread. Okay, inside that also write the run method. I will explain the importance of this run method later. First, try to understand how do we create threads in multi-threading in addition to the main thread. Already explained in the exception handling. Okay, main is the only one thread in that program. So already explained, till now we have written only single threaded programs. Now only we have started to write the multi-threaded programs. So what is the difference between single-threaded programs and multi-threaded programs is, in single-threaded programs, there is only one thread. And the name of that thread is called main. Main is the name of the thread in single-threaded programs. But whereas in multi-threaded programs, in addition to the main thread, we can write any number of threads in addition to the main thread. Remember, main must always be there in any Java program. Without main method, we can't write any program in Java. That's why in multi-threaded programs, in addition to the main thread, okay, we can write any number of threads. Okay, but how do we write any number of threads? Is by using either extends thread class or implements runnable interface. So there are two ways to create a new thread. Okay, now I am explaining how do we create a new thread in addition to the main thread by using extends class. So if you understand this one, it is nothing but a new thread. Okay, so how do we write a new thread in multi-threading is by taking class only. With respect to classes only, we will create multiple threads. There is no other way, because the entire Java depends on classes only. That's why think like this. Each thread is nothing but a class. But how do we write that class? You can't write as you like. If you write class test, means it is not a thread. But if you write class test extends thread, okay, means it is a thread. Or the other way is class test implements runnable, means that is also a thread. So to create threads in multi-threading, we have to take the one class that must extend either thread class or that must implement runnable interface. So these are the only two ways to create a thread in multi-threading. If you understand this concept, the remaining part of multi-threading is very, very easy. So thread is nothing but a class, but it is not a normal class. That class must extend thread class or that class must implement runnable interface. So when a class extends thread class, means that class is behaving like a thread. Okay, or if a class implements runnable interface, then that class is behaving like a thread. So how do we create threads? Means it is nothing but write like this. So this part is nothing but a thread. That is class my thread extends thread. First I will explain only extends thread. After that I will explain implements runnable. Okay, there are two ways to create threads. That is, first way is by extends thread class like this, and the second way is by implementing runnable interface. So here class my thread extends thread. Inside this class I have written run method. Inside the run method I have written the functionality of that run method. First try to understand this class. This is a thread. Okay, this is only one thread now in addition to the main thread. Suppose if you want to write two threads in addition to the main thread, then how do we write is in the same way. That is class my thread one extends thread, that this is one thread, and take one more class my thread two extends thread. So inside that also write the run method. Okay, so this is one thread and class my thread two is another thread. So in addition to the main thread, here we have two more threads. So how do we create a thread is like this. So once you understand this creation of a thread, next I will be already explained now. This class is for creating one new thread. Why? Because this class extends thread. Means we can easily understand whether it is a thread or not. Suppose if you write simply class my thread, okay, without this extends thread, means it is a thread. It is not a thread. Because if you write class my thread with the same code, then it is not a thread. But when it is a thread is class my thread extends thread, means it is a thread. Now you can easily identify Okay, which is a thread and which is not a thread. Threads are nothing but classes only. When we say that it is a thread, means any class which extends thread class or any class which implements runnable interface means that is a thread. If you write normal class, then it is not a thread. Okay, first try to understand the thread. So it is a thread. Here I have written one thread. Okay, after that I am taking one more class, that is thread demo. Inside that, as usual, I am writing the main method, and inside the main method I have created an object for the child class, that is my thread. You know, class my thread extends thread means, you know, inheritance, no? Thread is the super class and my thread is the subclass. So in inheritance, always we will create the object for the child class only, yeah? Because through child class object, we can access both super class members and subclass members. That's why in inheritance, when you apply inheritance, always try to create the object for the subclass only. Through this subclass object, we can access both the superclass members and subclass members. Okay, you know the inheritance concept only. That's why here I am creating the object for subclass. So that is my thread t is equal to new my thread. This is the object creation for subclass. Okay, next. After that, what I am writing is t dot start. So I will explain t dot start later. Okay, after that I am writing one more for loop. Okay, to repeat, this for loop is repeated 10 times, and inside that for loop I have written main thread. Means to say that it is the part of main thread. Already explained, main is always one thread in any program. Whether it is single threaded programs or multi-threaded programs, main is always one thread. Okay, in single threaded programs, main is the only one thread, but whereas in multi-threaded programs, in addition to the main thread, I have written in this program one more thread. And now, is it the same program or different programs? You know, no, inside one program or inside one file, we can write any number of classes, no? So I can consider this as only one program. Now, understand the definition of process-based multitasking. Not process, thread-based multitasking. So, what is the definition of thread-based multitasking? Already explained, no? Now try to understand with this program, thread-based. Executing several tasks simultaneously, where each task is a separate independent part of the same program. So here I am taking only one program. This is only one program. So inside this program, I have how many classes? 2 classes. And how many threads? 2 threads. Why? Because why this program consists of 2 threads is already explained. Main is always a thread. So this is main is one thread for me, and also this my thread is also another thread for me, because class my thread extends thread means it is behaving like a thread. So is it part of the same program? Yes. We are considering multiple parts. This is one part of the same program. This is another part of the same program. But these 2 parts are independent parts. These 2 parts are separate and independent parts of the same program. So each part is called a thread. So in this program, how many threads are there? 2 threads. This is one thread. Okay. This is another thread. So here we have 2 threads. That's why this program is it is a program on multi-threading. Why? Because this program consists of 2 separate independent parts, and each part is nothing but a thread. And here in this program we have 2 threads. Okay, that's why in the till now we have written only programs on single threaded programs, because in the previous programs we have not created a separate thread like this. We have only one thread, that is main thread, in all the previous programs which are single threaded programs. But coming to the multi-threaded programs, in addition to the main thread, we are creating one more thread, that is this thread. Okay, how do we identify whether it is a thread or not is by using either extends thread or implements runnable. That's it. Okay, based on these 2, we can identify whether it is a thread or not. Okay. So up to this, okay, we know it is a program on multi-threading, because in this program we have only two threads. That is, one is main thread and the another one is my thread. Okay, these are the two threads. After that, how do we save this file? Because it is a single program, no? Even though it consists of two threads, but it is a single program only. So how do we save this file is, because main method is there in thread demo class now. That's why I will save this file with threaddemo.java, and I will compile with java c threaddemo.java, and when you execute java thread demo. So if you execute with java thread demo, what will happen? I will explain now. Okay. Now I am executing this program with java thread demo. So when you execute with java thread demo, JVM will go to the thread demo class, and first it will invoke the main method in the thread demo class. So JVM invokes the main method of thread demo class during the execution time. Already you know this one. So first we will see what is the first statement inside main method. So my thread t is equal to new my thread. Means we are creating an object for child class, that is my thread. The superclass for this is thread. Thread is a predefined class which is there in java.lang package. That's why here in this program, when you write extends thread, here no need to import to any other package, because you know default package which is imported to each and every program is import java.lang.star. Means thread, means this thread class is imported to your program. Means thread class is available to your program. So here we have written explicitly only two classes. They are thread demo and my thread. But already one import statement is available by default, that is import java.lang.star. So all the classes and interfaces which are there in the java.lang package are imported to your program. So among them, I am using thread class. So class thread, it is imported to this program. So in addition to these two classes, that is thread demo class and my thread class, I am using predefined class thread also. It is automatically imported to your program. So with respect to this class thread also, I will explain this program. Why? Because here I have written class my thread extends thread. Means you should know what is thread class and it is there in which package, and what is the code which is available in the predefined class thread, and how it is linked to our program. Okay, now I will explain all these things. Now first, before execution, first I will explain thread class. So class thread, it is a predefined class. All the predefined classes are public classes. That's why we should write public class thread. Okay. Next, it is there in which package? Java.lang package. Okay. Next, public void inside the thread class. Okay. I will explain only two methods. In addition to these two methods, there may be many number of methods, but now I want only these two methods which are available in the thread class. So what are the two methods? First I will explain start method, then I will explain run method. These two are very, very important methods which are there in the thread class. If you understand these two methods, okay, which are available in the thread class, then only you can understand multi-threading concept. Don't by heart the programs and write in the exam. There is no use if you by heart multi-threaded programs. If you by heart, it will take only 2 minutes. But there is no use if you by heart. When you go to interviews, you can't explain the flow if you by heart. That's why flow is important and concept is very, very important. Once you understand the first program on multi-threading, the remaining programs you can understand on your own only. Don't by heart the programs. Okay. And now first I will explain thread class. So inside the thread class, most two important methods are there. They are start method and run method. We will see what are these two methods, why they are used in multi-threading. Okay. Now what is the start method? Public void start. So here inside the start method, Okay, the code is there for doing all these. What is there first? What is the first one? So inside the start method, the first thing is it will register our thread with the thread scheduler. Okay, next second one is it invokes the run method. So start method of the thread class. Start method of the thread class is the heart of multi-threading. Okay, so inside the start method, it is registering our thread with the thread scheduler, and it is invoking the run method. So invoking run method means, no, run, put semicolon. So invocation of run method is nothing but from this start method we are invoking run method, means from this statement it will go to this run method definition. So what is there inside the run method means it is null implementation. Nothing is there. So run method of the thread class is with null implementation, but start method of the thread class is very, very important. Here in the first step, it is registering our thread with the thread scheduler. Then only one new thread is created, and that new thread is registered with thread scheduler. This is the first thing it will do inside the start method of the thread class. And the second one is simply it invokes run method, means from this it will go to this method with null implementation. Again it comes back to the same statement, and after followed by these two, okay, there can be any number of statements. Okay, thousands of lines of code is there in the start method. It is only for JVM purpose. We need not worry about the rest of the code in start method. Now only try to understand the start inside the start method of the thread class. First thing is it will register our thread with the thread scheduler. After that it invokes the run method of the same class. But run method of the same thread class is having null implementation. Only simply it invokes means it goes to this method, and it comes back again to this statement. After that several statements are there. The JVM will execute all these statements. Okay. So this is the start method of thread class. This is the run method which is having only null implementation. Understand these two methods. Now I will link up okay, these two methods in our program. Now we will start. Okay. Now when you execute this program with Java thread demo, then the JVM will invoke the main method first. After that, inside main method, I have created the object for child class or subclass, that is my thread. Next, with this child class object, I am invoking start method. So t.start. This is normal Java program only. So so how do we create subclass object? With that, how do we access the members of the subclass? No, like that only I am doing. Nothing new here. And now here, this is very, very important statement. I will explain this one. So t.start. T.start means, because this is the reference variable for subclass now. So t.start means it will go to the subclass, that is my thread, and it will execute the start method. It will execute the start method. But inside the my thread class, there is no start method, no. But using inheritance, that is class my thread extends thread, means the entire code of this thread class is inherited to this subclass. Means, see, start method is available to this class my thread. So when you write t.start, that is when you invoke start method with subclass object, that is with t, first it will go and check whether that subclass contains start method or not. When it is not having that start method, it will inherit this, or it will execute the start method of its superclass, because the entire code of this superclass is part of this subclass due to inheritance. Whenever you write extends thread, means the entire code of this thread is inherited to this one. Means start method is part of this my thread. That's why when you write t.start, it will execute start method of this thread class. So t.start is nothing but invocation. T.start method is nothing but invoking the start method of the thread class. Okay, because we have not written start method inside this subclass my thread. That's why it will execute the start method of its superclass, that is thread class. So t.start means this will be executed. So inside start method, what is there? So start method will register our thread with the thread scheduler. Which is our thread? Where is it? This is our thread, no? Means this thread is registered with the thread scheduler using the start method of the thread class. Okay. After that, what it is doing? Still we are in the start method only. First it will register our new thread with the thread scheduler. After that it invokes the run method. No, from the start method we are invoking the run method. Means we are invoking this one. But here is it the overriding run method of this method? You know overriding concept, no? Okay. See, run method is there in both superclass and subclass. So inside the subclass, we can override the superclass run method. So this run method is called the overriding run method of the thread class. So inside the overriding run method, I am writing the functionality of this thread. Thread means it has to do some functionality, no? So where we should write the functionality of that thread is inside the run method. That's why always we should override the run method of the thread class in this child class. So inside the overriding method or inside the overriding run method of this my thread class, I will write the functionality of this thread. This for loop is nothing but the functionality of the thread. Means each and every thread has to do some functionality, no? So the functionality of that particular thread will be written inside the overriding run method. That's why whenever you create a new thread, always we must override the run method of this thread class, because this the run method of the thread class is having null implementation, no? That's why we must override. There is no other alternative. When you define a thread using extends thread, we must write some functionality, no? So where we should write that functionality of that thread is inside the overriding run method. So that is the importance of overriding run method. So inside the run method, I am writing this one, no? This is nothing but the functionality of this thread. Okay. Now try to understand. So here we have written the object for the child subclass, and with that subclass object I am invoking the start method, because start method is not available in the subclass, so it will execute the superclass start method. So when the start method is executed, first it will register our new thread. This is our new thread now with the thread scheduler. After that it invokes the run method, but here it is having here overriding run method is there. That's why JVM will execute this overriding run method as part of the start method. Okay. So when it executes this run method, what will happen? This for loop is repeated 10 times. Okay. With the child thread like this. So this is the functionality of the thread which is written in the overriding run method. So after execution of this, it will come out of this start method. Okay. So overriding run method is part of start method only. Next. So here I have written p.start. Okay. After that, here I have written one more for loop. No, this is the functionality of the main thread. Remember, this is the functionality of the main thread, and inside the overriding method, we have written one more for loop. This is the functionality of the child thread. So multi-threading means two threads are executing parallelly. That is nothing but multi-threading. Minimum two threads we must take in multi-threading. That's why initially I am explaining the program with two threads. So what are the two threads in this program is main is one thread, and the functionality of main thread is this for loop. And what is another thread? This my thread is another thread because it extends thread class, and the functionality of this my thread is written inside the overriding run method. So here how many threads are there? Two threads. Inside each thread the functionality is I am taking for loop, which is executed 10 times. Here it is executing child, it is giving child thread. Here it is giving main thread. Now understand the concept. So when you execute the program, again I am repeating, JVM will execute the main method first. Inside the main method, first object is created for the child thread. Child thread means object is created for the my thread, and that is subclass of thread class. And with that reference variable, I am invoking start method, because we have not overriding here we have not written start method. That's why it will execute the thread class start method. This thread class start method is nothing but we will register our new thread with the thread scheduler. After that, it will invoke the run method. But here overriding run method is there. That's why from this the control goes to this overriding method, overriding run method, and it will execute this for loop. And the next, so whenever you write p dot start method of the thread class is invoked, and it will create a new thread, and it will and it will register our new thread. It will not create, it will register our new thread with the thread scheduler. Means our thread is registered with the thread scheduler using start method of the thread class. So these two statements are very, very important. So start method of the thread class is registering our new thread with the thread scheduler. Means at this point, two threads are created. One is main thread and another one is my thread. Okay. Whenever you write t dot start, at this point, two threads are running. First one is main thread and another one is my thread. So when two threads are, okay, so after t dot start, we have two threads like this, main thread and child thread. Okay, this child thread, my thread is registered with the thread scheduler using start method of the thread class. So after this statement, we have two threads which are running simultaneously or parallelly, not one after the other. That's why here we have two threads, main thread and child thread. No, so this is the functionality of main thread and this is the functionality of child thread. Now what is the output? Now I explained the flow. No. So what is the output? We will see later. First I will explain some more points. Here, what is job of the thread? Is it job of the thread? Inside the overriding run method, we will write the job of the thread. Each and every thread has to do one functionality. So the functionality of that thread we will write in the overriding run method. If you take 100 threads also with different names, my thread 1, my thread 2, my thread 3, which extends thread class. If you write 100 threads also, inside each and every class, we should write overriding run method to write the functionality of that thread. This is very, very important, overriding run method. Okay, next. So this one is for, it is giving the job of the thread. Next, is it the definition of the thread? Yes. For each thread, we should write class my thread extends thread or class my thread implements runnable. So this is the this is nothing but this body. Okay, this open brace to this closing brace. This is called the definition of thread, and this open brace to this open brace, it is called the functionality of the thread. So inside the overriding run method, we will write the functionality of that thread. Okay. So try to understand. If you understand this, we can write any number of programs on multi-threading. Okay, next. So this is the thread. Next, if you see, these two statements are important. This is the instantiation. Means we are creating the object for my thread class. Okay. Next, after that, t dot start. It is nothing but starting a new thread. Means we are registering our new thread with the thread scheduler using the start method of the thread class. So this is must. Otherwise, your thread is not registered with the thread scheduler, means it is not a thread. It is normal class. That's why t dot start is must. Next, after this statement, two threads are there. Okay, main thread and child thread. Main thread is nothing but this one. Child thread is nothing but my thread. Next, this is the functionality of the main thread, and this is the functionality of the child thread. Okay. If you understand the first program, remaining programs you can understand easily. Next, now here the doubt is what will be the output when you execute this program. So after this T dot start, two threads are executing simultaneously or parallelly, but which thread is executed first and which thread is executed last, you don't know, no? That's why what is the output for multi-threaded programs means you can't get the exact output when you execute the program. If you execute 10 times the same program, you will get 10 different outputs. Because which thread is executed first, we don't know. It is based on the thread scheduler. Whenever thread scheduler allocates the CPU for that particular thread, at that time only the functionality of that thread will be executed. So the output for this program is you can't guess. So thread scheduler, here thread scheduler plays very, very important role, because thread, operating system, no, like that here also. So waiting queue is there, inside that the threads are waiting. So whenever whenever thread scheduler allocates CPU for a thread, at that time only the thread will enter into the, and the thread allocates the CPU means it will execute its own functionality of that thread. So thread scheduler, if here it is, if several threads are waiting to get a chance for execution, means all are in the waiting queue, then we can't expect which thread will get a chance first for execution. It is decided by the thread scheduler. All the threads are in the waiting queue, remember. It is a part of JVM. So for the previous program, we have two threads which are in the waiting queue. One is main thread and another one is child thread. Child thread is nothing but my thread. So when these two threads are waiting in the waiting queue, then which thread will be allocated CPU by the thread scheduler, nobody knows. Okay, so here it is a thread scheduler. It is decided by the thread scheduler. It is a part of JVM. Okay, and whose behavior is vendor dependent. Okay, hence in a multi-threaded programs or in multi-threaded programs, there is no chance to tell exact output, but we can provide possible outputs. So what are the possible outputs? What is the functionality of the child thread? For loop, it is repeated 10 times and it will give you child thread. And the functionality of the main thread is again for loop, which is repeated, which is executed or which is executed 10 times with the output main thread. So here we are giving only possible outputs. So 10 times means 20 times now. For loop, two for loops. First one for loop is 10 times and another for loop is 10 times. Like that, here you will get 20 statements. Suppose if the thread scheduler allocates the CPU for main thread, then main thread, okay, until the completion of the main thread, okay, it will not allocate the CPU to child thread. Then in that case, what will be the output? First main thread completes its execution. That's why main thread 10 times followed by child thread. This is one possible output. In the same way, another possibility is, suppose if the thread scheduler allocates the CPU to the child thread, that is my thread, then the for loop is executed 10 times. Okay, this is the functionality of child thread. That's why 10 times followed by, suppose if the CPU allocates, suppose if the thread scheduler allocates the CPU to main thread, it will execute. This is one possible output. This is one possible output. Next, another possible output is, this may happen because first it will allocate, thread scheduler allocates the CPU to main thread, but it will start its executing that for loop. But after executing for loop only one time, at that time again the CPU, the CPU is given to the child thread by the thread scheduler. Then what will be the output? Main thread, next child thread, next main thread, or child thread, main thread, main thread, like this, or main thread 2 times, child thread 1 time, next main thread 5 times, child thread 1 time, like that. We don't know the exact output. In multi-threading, we don't know the exact output. So if you understand this first program, this is very, very important. Try to correlate this program with the thread class. Otherwise, you can't follow these multi-threaded programs. Or you can by heart the programs. Okay? But when you go to interviews, you can't answer the questions on multi-threading if you by heart. That's why see the link here. Here we are invoking start method, but which start method is executing? Thread class start method is executing. So what is the role of thread class start method is, first it will register our thread with the thread scheduler, then it will invoke the run method. But when it invokes the run method, it will invoke our overriding run method. You know overriding concept, no? If inside the child class, if it is having its own method, then it will not go for the superclass method. That is overriding, no? So inside the start method, it is invoking the overriding method. Overriding run method means this for loop is executed 10 times. Like that, after p dot start, we have written the functionality of the main thread, that is also a for loop with 10 times. But which one is executed first, all these we don't know. Okay. So these are the possible outputs. This is the output for the, please execute this program in the lab. It is not visible. Next, try to understand, all these are very, very important. What is the difference between t dot start and t dot run? Already explained t dot start, no? T dot start means it will execute the start method of the thread class. Okay. So in case of t dot start, a new thread, what is the importance of the start method of the thread class is, a new thread will be created which is responsible for the execution of run method. So inside the start method of the thread class, first new thread is created and it is registered with the thread scheduler, and then it is executing the run method. Okay. Next, in case of t dot run, suppose in place of t dot start, if you write t dot run in the same program, what will happen? No new thread will be created and run method will be executed just like a normal method. Okay, normal method call by the main thread. So okay, suppose in the above program, if you replace t dot start with t dot run method, okay, in place of t dot start, if I write t dot run, what will happen? This is the object for the child class now. Then you write t dot run, it will go to the class my thread and it will execute this run method. So how many times this is executed? 10 times, followed by this is executed. So if you write t dot run here, then first child thread will be executed 10 times, followed by main thread will be executed 10 times. Means it is like normal program. T dot run means this will be executed. Means now it is not behaving like a thread, even though if you write extends thread. Okay, even though if you write extends thread, but it is not behaving like a thread. Why? Because we have used t dot run method in place of t dot start. When you write t dot start, then only the thread class start method is executed and it will register your thread with the thread scheduler. That's why start method of the thread class is playing very, very important role in multi-threading. Unless you invoke the start method of the thread class with this statement, no new thread is created and it is not a multi-threading program. If you write t dot run here, it is behaving like single threaded program only. Why? Because our thread has not registered with the thread scheduler. No, only main is the one. Two threads are executing parallelly. One is main thread and another one is. That's why t dot start is very, very important to register the thread with the thread scheduler. Here what I have written, in case of t dot start, if you write t dot run, in the above program, if we are replacing t dot start with the t dot run, then the output you can guess it is single threaded program only, no? And that's why first it will go to the my thread class and it will execute that for loop with child thread 10 times, followed by again it comes back and it will execute the left of the remaining part of the main method, which is the for loop with main thread. That's why this is child thread 10 times followed. It is like normal program, means it is a single threaded program. It is not a multi-threaded program. That's why what you can understand is in multi-threaded programs, T dot start is very, very important. Okay, without T dot start, there is no concept of multi-threading, only single threaded program. Okay. Now, what is the importance of thread class? Already explained. No? The importance of thread class start method is start method present in the thread class is responsible. This is very, very heart of the multi-threading is start method of the thread class. Okay. Start method present in the thread class is responsible to register our thread with the thread scheduler, and then it is invoking the run method. Our run method, why I have written, you must override the run method of the thread class. Inside the overriding run method only, we are writing the functionality of the thread. So you must override the run method of the thread class and don't override the start method of the thread class. In the next class, I will explain these 2 points. Now, what is the role of the start method is public void start method. It is there in the thread class. So the role of the start method of the thread class is it will register our thread with the thread scheduler, means a new thread is created and it invokes the run method. When it invokes the run method inside the start method, it will invoke our run method, because always inside each thread we must write the overriding run method. Why? Because inside the overriding run method only we are writing the functionality of that thread. Okay. So these are the very, very important points. Okay. So next class we will continue. So first to try to execute the program and try to understand the concept of multi-threading. Okay. So in multi-threading, the start method of the thread class plays very, very important role. So without invoking the start method of the thread class, there is no concept of multi-threading, means no new thread is created. Means it is considered as single threaded programs only.